Hi dear student, this is Naveed Khan, your mathematics teacher. Now dear students, in today's lessons we will discuss quadratic equation and quadratic function. Okay, so at the end of this section you should be able to learn how to solve quadratic equation using the formula. Now already my dear student, you have already done in your previous classes. So now in this class we will discuss some advanced, for example, sketch the graph of the quadratic function by finding the coordinates of the intercepts and determine equilibrium price and quantity given a pair of the quadratic demand and supply function. Okay, so let's see how to solve it. Here, my dear student, these are the simple quadratic functions, quadratic equations. Okay, now in foundation classes we have already done this one, how to solve these quadratic equations. So now we are going to discuss its application. So here my dear student, we will discuss question number 4, revenue. This is revenue question, exercise 3.3 on page number 147. So let's have a look for the question. And the demand function for our manufacturer product is 2400 minus 6q. Okay, what is q? So where p is the price in dollars per unit, and when q units are demanded per week, find the total production that maximize the total, maximize the manufacturer's total revenue, and determine this value. So we need to discuss, we need to find out its maximum value. Okay, so let's have a look, my dear student. And we know that a revenue function is equal to q multiplied by p. Okay, price per unit multiplied by total number of units sold. This is called a revenue. This is the definition of the revenue. Okay, so q multiplied by p. So now my dear student, here let's suppose I wrote down this equation again. R is equal to pq. Okay, this is the equation for the revenue function. So here the value of p is already given, okay, in the above question. So here in this step I put here the value of p, which is 2400 minus 6q, and then multiply by q. So now this q will be multiplied with 2400, and this q, it will be multiplied with 6q. So here we have R is equal to 2400q minus 6q square. Okay, so now dear student, this is quadratic equation. If the revenue is equal to, let's suppose, 0, so this is quadratic function with a, the coefficient of a is equal to minus 6, the coefficient of q square is equal to minus 6, which is equal to a, and the value of b is equal to 2400, and the constant term which we have is 0. Here, my dear student, if you see this equation, so this equation is minus 6q square, okay, plus 2400 q plus 0 is equal to 0. Okay, because the value of c constant is 0. But my dear student, here the value of a is equal to minus 6, which is less than 0. So it means that the graph of the function is a parabola, and that opens downward. So we will get maximum at the vertex QR. Okay, so first of all we need to find out the vertex, what will be the maximum value. So we need to find out the vertex. Okay, so how to find out the vertex? Okay, I wrote down this sentence again. So the value of a, coefficient of q square is equal to minus 6, a is equal to minus 6, and b is equal to 2400, and the value of c is equal to 0. Okay, so we need to find out the vertex. For the vertex, this is the formula: q is equal to minus b by 2a. Okay, so the value of b we have is 2400. The value of a is also, we have a is equal to minus 6. Putting the value of a and b in the above equation, So here in this equation, at place of b I put here 2400. At place of a, the value of a is minus 6. After simplification, so the value of q is equal to 200. Okay, so these are the number of units sold. Now we need to find out the price. Okay, so the price, this q is equal to 200, so we will put this q is equal to 200 in the original equation. So the original equation which we have is, okay, so it was r is equal to 2400 q minus 6 q square. Okay, this one was the original equation. So after putting the value of q is equal to 200, okay, in this equation, so the value of r is equal to 240, 100,000. Okay, so my dear student, here the value, the vertex, so the vertex will become, okay, 200 and 240, 100,000. So these are the coordinates of the vertex. Okay, my dear student, so these are the vertex. Now my dear student, we need to find out x-intercepts. For x-intercept, we know already we have done this one in foundation. If you want to find out the x-intercept, then the y will become 0. Okay, so now we need to put here r is equal to 0, because here at the place of y we have r and at the place of x we have q. So here we need to put the y, the value of r will become 0 if we need to find out x-intercept. For x-intercept, the value of r must be 0. Okay, so here for x-intercept, for x-intercept, okay dear student, so we need to put the value of r is equal to 0. So here it will become 2400 q minus 6q square is equal to 0. Okay, so taking q is common, so we will have 2400 minus 6q is equal to 0. Okay dear student, now here we have two terms. The first term is q is equal to 0, or 6q is equal to 2400. Okay, so q is equal to, now dividing both by 6, so it will become q is equal to 400. Okay my dear student, so here we have two values of q. The first value of q, when q is equal to 0, and then in equation 1, if q is equal to 0, okay, here in this equation, so definitely if q is equal to 0, then r will become 0. Okay, now if q is equal to 400, so after, when q is equal to 400, first of all I put here q is equal to 0, then after this q is equal to 400, at place of q I have to put here q is equal to 400, so the same answer, the answer will become 0. Okay, so these are the x-intercept for the above function. So here we have is x coordinate, xr is equal to, we have 0 0. These are the x coordinate. Okay, and the second x, not x coordinate, x intercept, and the second x intercept, it will become 400 and 0. Okay, dear student, now we need to draw a quadratic equation that maximize the total manufacturer's product. Okay, so we need to, so this is the vertex, and these coordinates are for the x-intercept, and this is also x-intercept. Okay, now let's have a look how to draw a graph. So dear student, here we have a quadratic equation function. So our first, here we have 200, okay, on x-axis, and here will become 240, 100,000. Okay, so this is the vertex, this is the vertex of this quadratic, this parabola. So here is 200,000, and here is 250, and it will become, this point is 200, and 2040, 100,000. Okay, dear student, and similarly here this point is the point of intersection is 0 and 0, and here we have 400 and 0. Okay, so this is the diagram, the graph of this quadratic equation, and this vertex, this is the maximum manufacture point. Okay, now dear students, here question number 2. So we have the same question. Here the demand equation is already been given. The demand function for an office supply company's line of the plastic rulers is, so the value of P is already been given, 0.85 minus 0.00045 Q, where P is the price in dollar, okay, when Q units are demanded per day by the consumer. So here find the level of production that will maximize. So that will maximize, it means that we need to find out the vertex. So that vertex, the coordinate of the vertex, that will be the maximum point of this manufacturer's total revenue. Okay, so we need to, here at the end we need to find out the total revenue. So my dear student, again like the previous question, so here the value of total revenue is equal to P multiplied by Q. Okay, so price per unit multiplied by total number of units sold. So here R is equal to PQ. So the value of P is already been given in the question, which is 0.85 minus 0.00045Q. So putting the values here in place of P, and then this Q, it will be multiplied with first number, then it will be multiplied with the second number. So this is the final equation. R is equal to 0.85Q minus 0.00045Q square. Okay, so here my dear student, this is quadratic equation, and the coefficient of Q square is equal to A is equal to minus 0.00045, and the coefficient of Q is equal to 0.85, which is equal to B, and the constant term, which is also called y-intercept, is equal to C. Okay, since my dear student, the coefficient of Q square is equal to A, which is less than 0, so when it is less than 0, the graph of the function is a parabola, and it will opens downward, so we will get the maximum point at the vertex QR. Okay, dear student, so how to get the vertex? Here we need to solve this question. First of all, we need to find out the vertex Q. This is the formula. Q is equal to minus B by A. Putting the values of B and A, so we will get Q is equal to 944 units. Okay, it will be solved. Now we need to find out the total revenue. So the value of Q Okay, we have to put here in the in revenue equation. So the revenue equation is equal to R is equal to 0.85 Q minus 0.00045 Q square. Okay, so here the value of Q is equal to 944, so we need to put here Q is equal to 944 in this equation. Okay, so we here we have the total revenue, which is equal to 401.39. Okay, dear student, now it means that the maximum revenue that the manufacturers can receive is $401.39, which occurs at the production level of 944 units. It means that we need to solve, if we need to sell 944 units, then the total revenue will be $401.39. Okay, my dear student, how to draw the graph? So in the previous question you need to find out the x-intercept, and then it will be easy for you because the vertex is already been given. Here is QR, this is the vertex, so the coordinate of the Q is equal to 944. Okay, and the total revenue, it will become 401.39. My dear student, right after this just draw the graph for the quadratic equation. Okay, so thank you very much, my dear student. I took these two questions from the introductory mathematical analysis 14 edition. Okay, and one for computer science. And okay, so thank you very much, my dear student. Take care of yourself, and so we will see you in our next video. Thank you very much. Masalam, bye bye.